Hello, welcome back to More Fun Retro. This one is something very much outside my comfort zone, although I do kind of feel okay taking this one on. This isn't a PC Engine with just an obscure and opaque architecture that I will have to learn. Well, I mean, I will have to learn it, but it's all stuff that I kind of understand already. This is a recreation of the Jupiter Ace. This one is by Cees Meijer. I'm given to understand that's how you pronounce his name. And this was given to me very kindly by the amazing Pajaco. Paul saw me at RetroFest in Swindon a couple of months ago. Was it a couple of months ago? It feels like yesterday. And he handed me a box of all kinds of chips and spares and bits and pieces that I could use for projects, and this. And he said, well, the most exciting thing that he said was it doesn't work. He'd never been able to get it to work, which just my eyes lit up. And I have to have a small confession here. I instantly judged what I saw. Now, I'm not judging his workmanship. His soldering is spot on, really good. It is a very well made thing. But there's one thing that bugs me on this, and that is that all of the sockets on here, and everything is socketed, which is a good thing, they're all turn pin. And I don't like turn pin sockets for chips. No, it's a square peg round hole thing, literally, and there will be people out there that will die on the hill of turn pin sockets, and that's fine. You can do what you want and you can have your own opinion. I will not judge you. I'm just offering my own opinion, which is going to be different to some of yours, but I'm going to demonstrate why I don't like these. Now, the thing with turn pin sockets is upon first insertion, they might be fine. But if you take the chip in and out, the indentation it leaves in the socket will actually cause the socket to fail. And I thought that that was the case with this. And I said as much to Paul when he handed it over, that I thought it was the turn pin sockets and that I was going to have to take them all out and start again. But I'm prepared to be proved wrong, but I'm just going to show you something. I'm just going to grab this chip here, and I'm not even going to pull hard. That's just kind of fallen out with very little effort. And same with that one. All of these 14 pin chips do the same thing. They are barely hanging on. That one's okay. That one's okay. That one's okay. Oh, that one's coming out as well. Yeah, most of these are okay. These ones down here are also, that one's all right. I think it's just mostly these 14 pin ones, and they seem to have slightly different chips in than the. Oh, I think it might just be that the legs on the chips are thinner. They look in really good condition. They're brand new, as you can see there, and they are, is that a 74 LS logic chips, and all of these other ones are, they look slightly different, and they are still 74 LS, but if I take one of the ones that doesn't fall out quite so easily out, they do take a little bit of extra effort. But these are the ones that have got kind of tarnished legs, and they look a little bit more scuffed up around the pins. So they might be making better connection, but these could also be a problem because they are tarnished. But who knows? Who knows? I think that the RAM chip. So we've got, anyway, look, let's go through this. We've got logic here and logic here. That's fine. That's all to be expected. We've got 6116 RAM chips. I'm given to understand that this is about 6K memory, but I'm not sure on that. I do have a way to test those. I've got the Retro Chip Tester Pro, is the only tester I've got capable of doing these RAM chips because they're in the wider package. But we've also got an EEPROM here with some jumpers. I don't know what the jumpers do. I'm going to have to look that up on the schematic. But they are currently just not connected to anything. So that could be something that needs looking at. And a Z80 CPU. So the first thing I did before I switched on the cameras was to take every single chip out. Sorry, not every single chip, every single logic chip out and test them in the terrible logic tester. I only call this terrible jokingly because it winds people up, but it's fine. It works. It does the job I want it to, which was to check that all of these were reading as 74 logic in the correct. I'll show you a little demonstration. We could take that one out again, turn it on, and this is a 74 LS367. Press that, and it's, yep, 367. It actually comes up as HC, this one. Yeah, and that's an LS. So that could be a fake, but that's the problem with this. This can't tell the difference between HCT and LS. It can tell the difference, but the thing that worries me is that it knows for sure if it's a HC or for sure if it's an LS. But if it's HCT, I'm not sure whether it tests. It might test as a HC, even if it's a HCT. I didn't actually check all of these to see if they, let's try this. What is this one? Okay, this is an LS02, and this one tests as an LS02. So that is concerning. That's a potential problem for later, because this is a bit of a finicky machine. I know it needs proper timings and things to work. And if there are some fake LS chips in here, that could cause an issue. The other thing I've tested is the Z80 CPU, and I tested it in the CPU tester. It was testing as a CMOS chip, and I wanted an NMOS chip. It was one of these ones that was already in there. I can't remember which one it was, but I got my stock of, I've got loads of these off of AliExpress, and they are all marked exactly the same. 18th week, no, yeah, 18th week of 2034. But they're just rebadged, and this one was an NMOS, so I put that one in there hoping that it would give better better compatibility with this old design. Okay, so where do we start? The first thing to do, well, the first thing I did was just to check there was nothing was shorted. I inspected all of Paul's soldering, and even where there are these transistors, there's a few transistors, 1, 2, 3, 4, 5 transistors dotted about. They're the packages with the 3 pins very tightly together on the board. That's a transistor there, and that's a transistor there. So there are 6 pins in those 2 positions. They're really tight, but I checked them and they're not shorted. Let's just take a moment to talk about the sponsor of today's video, PCBWay. Right now, PCBWay is celebrating their 12th anniversary, and they're running some massive promotions throughout the month of July. If you're designing a new project, they're currently offering free solder mask upgrades to matte black, purple and pink. This applies across the board, whether you're spinning up a standard rigid PCB, a flexible circuit, or a rigid flex board. You can grab these premium colours at no extra cost. There is one crucial rule to keep in mind. Your order doesn't just need to be placed, it has to pass review within the event period to get the free colour upgrade. The promotion ends on the 31st of July, so make sure you upload your Gerbers with enough time for their engineers to greenlight the files before the deadline hits. Otherwise, it will revert to the standard pricing. Click the link down in the description to check out the 12th anniversary page and grab your free solder mask upgrade while the event is live. Huge thanks to PCBWay for supporting the channel. Now, let's get back to this Jupiter Ace. Now, this is an 8-bit micro, and it is something that I understand reasonably well with its CPU, ROM, memory and logic. There's also a 555 timer over here, which I believe is to help generate a back porch for the composite video output. We've got a flying lead for a speaker, a ZX81 style power socket, which Paul has very kindly given me this flying lead for, and I've tested this to find out which is the ground and which is the positive, and I've got my bench power supply set up accordingly. Oh, and there's a mic and earphone input and output here for tape decks. So we've also got a tack switch keyboard, and looking at previous builds of this, there is a 3D print files to make a Jupiter Ace replica. I think this is built so that it would fit inside an original Jupiter Ace case, but I'm not sure how accurate that is, but I'm quite interested in printing the case. And I've got my Bamboo Labs X2D waiting to print something over here, so maybe I will by the end of this video have something to put it in. We'll have to see. I'm not sure how much time I'm going to get to do that. Anyway, so what's wrong then? Well, the thing to do is to first of all turn it on and check for voltages, or actually is to turn it on and check my bench power supply, which is drawing 356 milliamps. Now, it was actually drawing a lot less than that with the CMOS CPU in here. And it has got this 7805 regulator just flying loose here on the side here, with no heatsink on it. I could add a heatsink to it, but that's going to get in the way, especially I'm going to be poking around in this area. Actually, I'll be over in this area. I might put a heatsink on it, I might not, but I'm only going to have it on sporadically, so it's not a problem. With that low current draw, it's not a problem to have it on for a little bit. So voltages are going to be, we can measure across a logic chip here, and we got 5 volts, 5.05, which is spot on, couldn't be better. I noticed that it has got a diode here, and I'm wondering if that's a protection diode that has been added to stop reverse current polarity, to stop reverse polarity causing any damage. Right, so the other thing I need to do is to see what it's displaying. So if you look over here, I haven't got this connected to capture. I have already switched this on, full disclosure, to find out what's going on with it. But if you look, that's not exactly a good picture. I have connected it to my capture setup, and it does not like it. It won't lock onto a signal at all. It just doesn't do anything. So that's why I've got this set up, so that you can see the output that it's creating. But that, as far as that's concerned, the output is just complete garbage. There's not much going on. Okay, so now the first things you do with any 8-bit micro are we've done the voltage check. That's the first thing you do, and resistance checks. I've done that as well. But the next steps, the third and fourth things that you do are to check for clock and reset. And that's going to be quite nice and easy to do, because we've got easy access to the CPU, so I can connect my probe ground up to that 7805 tab there, and then pin 6 of the CPU, 2, 3, 4, 5, 6 is the clock, and I turn it on, and that ain't right. That's just basically a 5-volt high with a small ripple. That's not right. So the other one to check is reset, which is pin 26. So 1, 2, 3, 4, 5, 6. And you can see that comes up reasonably well. I'm not sure which one of these is the reset capacitor, but there's probably a ceramic capacitor around there somewhere doing that job. Anyway, so there's no clock, and if you haven't got a clock, you haven't got a running computer. Now this is a piece of the schematics. I found the schematics which Cees kindly shared, the KiCad or KiCad, still don't know how to pronounce that, schematics, the whole thing for the Jupiter Ace. So I've got the whole thing to reference if, you know, if I get deeper into this. But this is the CPU, and this is the reset circuit here. This CNT0, I'm not sure what CNT is abbreviating. I'm going to say counter. Runs through a resistor and a capacitor into the base of this transistor, or pin 2. I don't know which is the base emitter and collector. That transistor is up here, Q2, and there's the capacitor, and there's a resistor, R7 and C4, R7. There's also R8 here, which is pulling the signal up to 5 volts, and this goes into the clock on the CPU. So we should see a good signal. If the crystal was okay, we should see on any of these points around here a good counter, a good whatever is it, 3.5 megahertz clock. So if I probe the left side of R7, we do get a clock at 3.24 megahertz, which is bang on. And there's the other side, or the left side of C4, the right side of C4 is slightly attenuated, and the right side of R7, now that's, you know, the left, this is the left side, this is the right side, that resistor and capacitor there, just to bring that down to the right voltage levels for the transistor to work. Now, this transistor is stuffed into the board. I can't get to the legs on this side of it, but the output of that is pin 6 of the CPU, is that one. Oh, interestingly, if I look at the address bus, some of the pins on the address bus, nothing. If I go down to some of the pins on the data bus, they're doing stuff. All right, but that is not a very healthy looking data bus, and I think that that's just where it's being driven from other chips on the board. There is the part of the circuit that deals with the video is actually working to some extent. It's trying to produce a signal. It's probably still making its back porch as it's supposed to, but all of that is still present on the data bus. But the CPU is doing nothing because it hasn't got a clock. It can't start. With the signal going from the crystal, which is over here, it goes through some logic chips as well. I think that's the CNT0 signal, goes through certain logic chips and ends up on the left side of the of R7 and C4. We've got the signal here. We've got the signal definitely on pin 2 of Q2, but it's not coming out. It's not on this side of that transistor. And with that, it looking like there is a little bit of a ripple there, but it's just been pulled to 5 volts. I am guessing that Q2 has failed, and that is a 2N2369. And I'm reliably informed that I can replace that with a 2N3904. I'm going to have to check that the pin out is the same though. Okay, according to what I could find, the pin out for the 2N3904 is the same as this 2369. This is a fast switching transistor, especially for this purpose, for clock signals. But I'm assured that this, even though this isn't a fast, you know, specifically fast switching transistor for this purpose, it will be fast enough for what it's going to be needed for in here. So the first thing I need to do is just pop that out. This should be fairly easy because it's one of these packages where the pins are so close together. I can just melt all 3 at the same time and pop the whole thing out in one go. Hopefully. Oh, it's hot. Ah, it's too hot. One of the legs is bent. Let's give it a big blob of solder on the back. like that. Whew. I can just wick up. Perfect. Smells nice. Smells of curry. Why does it, Paul? Why does your Jupiter Ace smell of curry? Pop that in. Actually, I'm going to stand this up off the board slightly. Not too much. Just so that I can get to the legs on this side. It just makes probing it a lot easier. Now the tricky bit is to get this soldered without bridging these pins. And I wouldn't normally do this. I am going to pop some flux onto these pins just to prevent any bridging happening, or to help prevent it. It won't stop it altogether. It depends how much solder I get in there, but the flux will just make the solder want to cling to the individual parts. I think that's got it. Give it a little look first with my eyeballs, and looks good to me. Actually, it looks like I might not have got the middle one well enough. That looks better. Just a microscopic amount, but it was just looked a bit light, and I didn't want it to crack at some point in the future. No bridging going on there. That's good. Did it make any difference though? I don't know if I can test this because the legs on it are very, very short, but I will grab a component tester, or I might be able to get it in there. Okay, that's actually tested good. That's a bit of a worry. Okay, I don't know if the other readings down there are making a difference. So it could still be bad, but it's testing as a transistor. But, you know, here's another test. Let's plug it in and see what it does. Right, here we go. Still doing the same thing. So the right side of that. Okay, we've got a clock on the left side of R7, but now we don't have a clock on the right side of R7. Okay. Bear with me. Right, it looks like I made a big assumption on the transistor pinout. I did a quick search and I thought that the pinout was the same, but I'm not entirely sure because this, what is it, 2369, PH2369. These 2369s are usually in a metal package with like a metal tab to show your orientation, and these are not the same. I don't think that they're a very common transistor, but I can just buzz out and find out exactly which ones are the emitter, base and collector by finding out which one is connected to ground, which one is connected to R7, and which one is connected to R8 or the CPU. So I can work it out. But first of all, I need to take this out because it's going to need to be reinstalled differently. So I'm going to take it out the same way as I took the other one out, with a big blob of solder and a pair of tweezers. Should be easier this time because it's not pressed down on the board like before. That's good. I'm mostly leaving this long to annoy people. I'm so petty sometimes. I do get people saying you should cut bits of your wick off to make it work better. It's working absolutely fine. Look at it. And I don't have to burn my fingers. There we go. Good wick that. That's in, what is that, Mechanic SR20 desolder wire. Good stuff. Right, so the emitter is pin 1, should go to ground. So there's ground there, and pin 1 should go to ground. So pin 1's on the right. 1. Base should be the right side of R7. So pin 2 should be the right side of R7. And that's that way. And then pin 3 should be the right side of R8. That is. So that looks right to me. So that's emitter, base, collector, and a 2N3904. Pin 1 being the emitter, pin 2 being the base, and 3 being the collector, emitter, base, collector. That's right. That's the right way around. So why didn't it work? There's nothing wrong with that. There's nothing wrong with this either. But it's not working. Okay, a little bit more investigation done. I've put the original transistor back in because it tests fine, and this one tested fine. The pinouts were correct. That wasn't the problem. I'm not sure why the output on this, which is, you know, I can show you the output. Well, actually, the output on R7 is that. That went completely flat. I'm not sure why. So I think it might be that this transistor is not quite up to the task. So I've gone back to the original one because that was doing a better job. I've checked for shorts and there isn't anything that I can see. The only thing that I haven't checked is without the CPU, whether it's the CPU that's, I mean, I've changed the CPU with different ones, but who knows? Do we get the clock signal here now? Because we weren't. So 2, 4, 6. No. Why? What? I don't understand how that can be. Okay, so I'm going to have to dig a bit deeper into the schematics and see if I can narrow down where the issue might be coming from, because I don't think there's anything else according to this part of the schematic. This side of this clock generation circuit is isolated from everything on this side. This is working, but as soon as it gets to here, it's not. As soon as it gets to here, I wonder if is R8 the wrong value? It's meant to be 270 ohms. Yeah, that's exactly right. That's meant to be, I think that's meant to be a 1K resistor, and that is. So I'm probing pin 6 of the CPU, and I still get nothing there. I have still got clock on the right side of R7, and I've got 5 volts at R8, and the clock disappearing on the other side of R8 before it goes off to the CPU here at pin 6. Now there are a couple of other places, I don't want that to get too hot, where CNT0 is generated, and apparently U9, which is this one here, which isn't one of the ones that falls out, but also U23. This is U23 is the master clock generator, and this is one of the ones that just falls out very easily. I've just bent one of those legs. A 74 LS86. Yeah, and that tests as a 74 LS86. It does have some quite tarnished legs. Let's give these a little buff with a fiberglass pen. It does come off very easy. I don't think that's going to be the problem. The socket doesn't look great, but I'm going to give it a clean. I'll pop this back in and see if that makes any difference. So nothing, absolutely nothing. I just wanted to give you a little view of this this socket here. This is U23 socket. You can see U23 is right there, and that's a good example of how one of these sockets can get damaged. So that's meant to grip the leg of this chip, but that bit there has split. That one's split there, and that one's split at the bottom. They've all, are they all supposed to be like that? Is there meant to be like a relief bit? Maybe it's not damaged. Maybe, yeah, all of them have got that cut in, but that expands and ends up not making good contact. So that one doesn't have a cut. Why? Oh, maybe it's there. I don't know the pinout of this chip. I can look it up, but I'm just going to probe around here to see which ones have got a good clock signal on, and see if I can find where this clock is coming from. It could be there. It looks very weak. Okay, so that one. It could be that one, which is pin 9. I'll turn that off again, put this back in and see if I can even see that. But I think that might be so weak. Now it's actually doing stuff. Maybe it needs this chip in to actually start generating things. There's nothing there. Okay, so there is. What on earth? That's data. This must be being used for part of the video generation as well. So I need to look up the output of that. Okay, I've had a little poke around, and this is what I've found. The signal starts around this area, I think U9 and U23, wherever it is, and the actual crystal itself, it's then sent over to this part of the circuit, and this transistor, I think, is supposed to boost it or do something to it, but it's not working. The signal is going into it. Well, actually, it's not quite going into it. It appears this when it is generated over here, it appears on the left side of this resistor here. Okay, there we go. There's the signal on the left side of the resistor, and on the right side of the resistor, it is actually, that is exactly as it should be. That resistor is supposed to lower it to 1 volt, but coming out of that transistor, which is connected to pin 6 of the CPU, is that signal, which is not what we're after. It should be more, well, it should look more like a Z80 CPU clock signal. I've eliminated lots of things. The resistor is a 1K resistor, and apparently, if one of the quirks of this type of circuit is that the current going into the base of the into the collector or into the transistor is not high enough, and it won't turn it on. So I've added another 1K resistor here, and that should bring that down to 500 ohms, just holding it across them. And if I turn that on now, it looks exactly the same. I can fiddle around with this and it doesn't really do very much. It increases it a little bit, and it's all pointing towards this transistor being faulty. I also ruled out this capacitor here. I don't know if this is going to test in here, which is in C4. That should be a 47 picofarad capacitor. Come on. 42, fine. That's not the problem, and it should work without that. That's just to make the signal nicer, if you like. Okay, so I'll pop that back in, just because that's where it belongs. Like that. That's fine. And then I've gone off looking for, well, the advice that I got, which I'm not going to say where it came from because some people don't like robots, said that a suitable transistor replacement would be a 2N3904, but it's just not fast enough for this purpose. But what is fast enough would be a ZTX 313, and I've got loads of these. Literally most of these are ZTX 313s. I'm sure that they all work. And these are what I take out of the RF circuit in ZX Spectrums when I'm doing a composite mod. That's a 312. So I can just pop one of these in the wrong way round, because I think that the pin out is the opposite way round. So I should just make sure that the flat side is facing the opposite way to the silk screen. 651 there. That's a nice one. All right, HFE 72, IE 664 microamps, and UBE 660 millivolts. Let's take this other one out again. Should come out easier this time. I'm going to put it in the same way round so I can confirm the pin out as well. Right, so we had HFE was 72, this is 46, 429 microamps, 664 and 6, they're very similar. And collector base emitter seem to be the same pin out, which would suggest that I think the emitter has to be on the right hand side. Let me just check that. Emitter is ground. Yeah, emitter wants to be on the right hand side. So it looks like that goes in the same way round. I've got loads of them, so the worst that can happen is I just pop this one and put another one in the other way around. I think that's all I need to do. I will just check that that's not shorted though. Nope, good. So we're looking for a clock signal at the CPU socket. Shouldn't need anything else just to get that signal there. That's the thing that's missing. 2, 4, 6. Ah! That is a very good clock. Ooh. Okay, so with video signal and a CPU, let's put a CPU in it. Oh, what do we get? Can you see? Yep, here we go. Yes, there's a cursor. It's working. Right, it's not working brilliantly. It's not locked onto my thing. My TV isn't locking onto it very well, but let's take this 555 timer out. I've heard that this can help. Well, it's better. Paul, I made it work. I wonder if that will connect to my capture now. That's recording. Okay, right, let's see if my capture picks this up. Yes. Oh, it's a better signal on there as well. Very nice. Looks like a working system. I don't know, right, I can program in BASIC, but fourth, way beyond me. And this failed, this computer, for a number of reasons. Actually, I just want to check something with this 555 timer again. Oh, it doesn't like that. Yeah, it really doesn't like that. I'll go without it. I don't even know if it's supposed to be a black on or a white text on black screen. Probably not. But I can look at that in a sec. Yeah, this failed spectacular. I think they only sold 8,000 of these before the company went bust. And most of the reason for that is it didn't hit the market that was around at the time. The Spectrum, 1982, the ZX Spectrum was setting the world on fire and selling millions. And this was in direct competition, but they aimed it at programmers, and they said that with fourth instead of basic, you can have something that's 10 times faster, which was probably absolutely true. But nobody knew how to program in it, only hardcore programmers. And I'm sure that they enjoyed it, but they weren't, you know, that wasn't a big market. They aimed themselves at too narrow a market to actually sell a decent amount of units. It was also a black and white only computer with some serious like memory limitations as well. I think it only shipped with 3K of memory, and usable was less than a K. So it was never going to be a world beater, but it's interesting that it's still around now, and I'm really grateful to people like Grant Searle and all of the other clever people, including Cees Meijer, that helped make this something that could enter my domain and allow me to have a little play with it. But saying that, no idea how to program in fourth, so maybe I should look up a simple type-in just to see if it works. But yeah, let's do that. Right, so space Hey. Well, that looks like it works to me. I've still got to test the speaker, but I think I'll save that for when I put it into a case. I think that's enough for now. You know, if this had been a very simple fix, which it was kind of a very simple fix, it was only just that single transistor, but tracking it down was a bit more complicated than I thought it was going to be. But I was toying with the idea of printing out the case in this video, but I might save that for another video at a later date. Oh, I've just noticed a capacitor folded over onto a resistor there. It seems to work. I have to concede that the the turn pin sockets seem to be working. My misgivings are maybe, I don't know, they might be justified in another instance, and they were certainly in the past for me. In an Amiga 500 build that I made back in 2024, I had to remove all of the turn pin sockets that I put into that build because they just gave up. Maybe these are just better quality ones. I don't know. You carry on doing what you want to do and ignore my terrible opinions. Right, thank you to Paul Pajaco for sending this to me, or to handing this to me at RetroFest. I will endeavour to put it into a case and make it look at least a little bit like a Jupiter Ace. It's probably as close as I'm ever going to get to one, having a look at how much the ridiculous amounts of money that they go for, which is, you know, with something that was only so few made, is no surprise really. But yeah, thank you for giving me this, Paul, and let me fix it. I will look after it. Cheers, mate. And thank you everybody else. If you like what I'm doing, then like and subscribe, and do the YouTube things. If you really like what I'm doing, then go and visit Patreon, where you can support me there, help me to make better and better projects, and with better and better quality. And you might have noticed that this angle is a little bit better. That's thank you to my patrons. I've also got some YouTube channel members now. If Patreon's not your thing, you can support me through YouTube channel membership. That's another option. I try to keep everything the same on both platforms, so you'll get early access and behind the scenes videos and updates and things like that. Things that I don't release to the public go on to my Patreon and YouTube membership. So if you see a YouTube video come up with members only on it, it's usually early access. You'll get it in a few days time, or a week's time, or a couple of weeks time, depending on how far ahead I am. Anyway, right, time to edit this. I'll see you in the next one. Bye.